I can catch it up on the YouTube repeat. Let me just pull up some of these questions here. All right. So the first question, and like I said, I don't have it printed out. I just have it on my screen, but I'll just write out the important things. So we have a nurse that's caring for a patient, and they're administered Ringer's lactate. They are told that the infusion is running at 150 milliliters per hour, and it's supposed to last for 12 hours. The drop factor is 20. And then we want to know what the drops per minute would be given the details. So let me pull this up here. Okay, so Ringer's lactate infusing at 150 milliliters per hour, and it's going for 12 hours, but how long it's going doesn't necessarily mean anything as far as calculating drop rate. Because remember, drop rate is just flow rate times the drop factor. And that'll give us our drop rate. The only thing we have to do is we have to convert hours to minutes in this problem. So the way I initially wrote this out, if I just put a times here, I'm already pretty much done with the problem. But let's organize it. 150 milliliters. Now it says per hour. I think we all know that 1 hour is the same thing as 60 minutes. Okay. Times the drop rate, or the drop factor, I'm sorry, which is 20 drops per milliliter. And at this point, we'll know we have set this up because we can eliminate milliliters. We're left with drops, and we're left with minutes. And so when we do this, we do 150 times 20. Helps if I leave my calculator on. So 150 times 20 is 3,000 divided by 60. And you'd get an answer of 50 drops per minute. So this is just an additional example of a flow rate, drop rate question that's not currently on the practice test, but you can see that everything that I said is essentially, it is the same. It's just worded differently. That's all. So we're going to see if we can do another one here. Another example, it says a nurse is preparing to give somebody an IV solution that's 150 milliliters to infuse over 3 hours. The drop factor is 10, and we want to know how many drops per minute. So again, it's 150 milliliters again. Okay, it's infusing over 3 hours. So this is where we have a difference for what we saw up here. And then the tubing is 10 drops per milliliter. Now remember, you're going to be given the drop factor. So this is given to you. And if it's not given to you, a lot of times they'll use the term like micro tubing, and that would be 60 drops per milliliter in case they don't give it to you. Okay. Now, one of the things you want to do is you want to convert hours to minutes. So you could do that in a dimensional analysis way, or you could just take 3 times 60, which is 180 minutes. Okay. So if we ignore the 3 hours and convert that 180 minutes, now we're done with any kind of conversions. And all we got to do is take 150 times 10 divided by 180. And let's see what we get. Now, these are problems I have not done yet, so I'm working them out for the first time with you as well. So 150 times 10 is 1,500, and then divided by 180, we're actually going to get 8.3333. And if you know anything about drops, you can't give a fraction of a drop or a decimal of a drop. So you're just going to round this to the nearest whole drop. So it would be 8 drops per minute. You would not do 8.3 drops per minute because again, you can't give a fraction of a drop. You can give a fraction of a milliliter. You can bring that down. You can certainly do that, but a drop is literally, that's what it is. It's a drop. So you can't do like a decimal drop. It just doesn't work that way. Okay. All right, let's see. Okay. So here's an example of something with using an IV piggyback. So sometimes IV piggyback is abbreviated as IV PB. Okay. An IV piggyback. So what I'm going to do is just delineate what I'm doing here. IV piggyback. So we're administering some medication via IV piggyback for 20 minutes. So I'm just going to write that down because that might be important. The available drug, it's available as 1 gram, and that's going to be in 100 milliliters. Okay, so that's what it says. The drop factor is 15. And we want to set the infusion pump to get the drops per minute. Okay, so this is a little bit confusing, right? Because you have a whole bunch of different factors here. You have 20 minutes, which is time. You have 1 gram, 100 in 100 milliliters, and then you have 15 drops per milliliter. Okay, so you have a couple of different factors. So what do you do with it? So I'm going to bring you back to the definition of a drop rate. I need a flow rate, which is volume over time, times the drop factor, which is drops per milliliter, which is given to you, and that'll give me my drop rate. So looking at all these numbers, I have 20 minutes, I have 15 drops per milliliter, and I have 1 gram per 1,000 milliliters. So let's start with what we know. We know that this is our drop factor here, right? So we're good with this. Okay, so we know that that's the drop factor. We don't have to guess about that. But what we need to know is, how do I get my flow rate? Well, my flow rate is always going to be volume over time. So you're usually told not to ignore pieces of information, but this whole thing, keep in mind that this 1 gram of this drug, is in 1,000 milliliters of the IV. So my volume is 100 milliliters. My time is 20 minutes. So I'm not going to factor in. So this is important, okay, for picking the right medication, because I wouldn't want to put 1 gram of vitamin C in there if I'm being called to put in 1 gram of, something else. Okay. So I don't want to put the wrong thing in there. That's why that's important. But as far as calculating flow rate, all I care about is the volume. So what's the volume? 100 milliliters. What's the time? 20 minutes times your drop rate, which is the 15 drops per milliliter. Okay. Now, I know you're not seeing the question, and I do need to type some of these up and just kind of change the questions up a little bit before I can just kind of give them out freely, which is why I'm not showing you the whole questions. But I gave you all the pieces of information that were there, including what was not needed, which is that 1 gram. Okay. So when I do this calculation, 100 times 15 gives me 1,500 divided by 20, and I'll get 75 drops per minute. So this is the way that would show up. But notice that the way you set it up, the way you solve it is exactly the same every single time. You take the flow rate times the drop factor, and that will give you the drop rate every single time. Okay. So I just wanted to show you a few of those. I do have a few more, but if you have questions, shoot.
Did you say 100 times 15?
I apologize. You're on mute. Go ahead, Keisha.
Did you say 100 times 15, or is it?
Yes, 100 times 15, and then divide by 20.
Okay.
Sorry, I was just going through all that, and I realized that I put the mute down, and so I didn't even know if anyone was talking. So sorry about that. So if you have any questions, please let me know. Just you can type it in the chat box, like what number you want me to work on, or if I have more examples of a particular number that you want to see, just let me know and I will see what I can do.
Can you do 22 again?
Sure. Okay. Oh, yeah. Okay. So 22 is the Pfizer pen question. It says the order is Pfizer pen, 750,000 units, IM stat Q6H. And then it says using the information below, choose the strongest concentration and determine how many milliliters you will administer to the patient. Now, one of the things that you need to know about this particular question is there's two pieces of information here. Okay, well, there's three. There's what was ordered, so that's important. Then there's the milliliters diluent added, and then the units per milliliter solution. Now, in order to calculate how much milliliters to give them, I don't need to know this. Okay, this table right here is extra information. So you can just cross out that table because that just tells the pharmacy how much deionized water to add to the powder to get to what you're looking for, which is the units per milliliter solution. So I look here and I choose the strongest concentration. I have 250,000, 500,000, and 1 million. 1 million per milliliter is the strongest of the three concentrations. So solving that question looks like this. Try and get fancy here with my paper positioning. I'm going to take my ordered, which is the 750,000 units. But I don't want units. I want milliliters. So I need a way to convert milliliters to units. And that's where I have the 1 million units per milliliter. Get rid of units. Then I'm going to take 750,000 divided by 1 million. My suggestion is because you're using just a basic 10 key calculator when you're doing these things. You have 4 zeros, 4 zeros, cross out the smallest number of zeros. 75 over 100 is much easier to type into your calculator than 750,000 over 1 million, especially with the calculators that you guys will be using. And then your answer is 0.75 milliliters. Do not round that to the nearest tenth. Any number less than 1 is going to get rounded to the nearest hundredth place. So leave it as 0.75. That would be the correct way to denote that. Good question. Okay, so the next question was looking at 23. Okay, this is a good one. All right, so 23 says that we have, we're going to administer 2 different medications, both as an injection. I have Vistaril and Meperidine. The order is Vistaril 60 milligrams and Meperidine 85 milligrams. And I want to know the total volume. So I know the milligrams, but I need to convert those milligrams to milliliters. So you're basically going to do what you already know how to do. You're just going to do it twice. You're going to convert milligrams to milliliters for Vistaril, milligrams to milliliters for Meperidine, and then you're going to get, you're going to take the 2 milliliters and add them together. And that's what you're going to do. So Vistaril is available at 50 milligrams per milliliter, and Meperidine is available at 75 milligrams per milliliter. So let's start with the Vistaril. I'll just denote that with a V. And we'll say the order is 60 milligrams I have available 50 milligrams per milliliter. Okay. So that's, I'm just setting up that the first part of it. The second one says the meperidine is 85 milligrams is the order. And then available is 75 milligrams per milliliter. So I'm going to set it up the exact same way, 75 milligrams per milliliter. If you're writing the 75 underneath the 85 and the 50 underneath the 60, we're all doing the same thing, okay? So 60 divided by 50 gives me 1.2 milliliters. And then 85 divided by 75 gives me 1.1333 and just keeps on repeating. And so what we're going to do is we can round that to the nearest tenth. You're going to put those two together. 1.2 plus 1.1 will equal 2. Helps if I use two hands. 2.3. And then I'll just make sure there wasn't a problem with the key. The key says also 2.3, so hopefully that's right. You've taken that course, you know the stuff, and it's just a matter of like just sitting down, practicing, like you said, getting into the routine, and then you'll be fine. But yeah, that's why we do this live. So it's not just me answering.
Yeah, well, thank you.
Yeah, you're welcome. Absolutely. Okay, so 16 says that the tubing package is labeled as shown. So you can see here that there's a big number 15, and that says 15 drops per milliliter. You're ordered to administer dextrose 5W IV solution at a rate of 75 milliliters in 25 minutes. What is the flow rate in drops per minute? So again, remember, to calculate drop rate, I need two pieces of information. I need the flow rate and I need the drop factor. When I have those two pieces of information, I will get my drop rate. So my flow rate given is 75 milliliters, 25 minutes. My drop factor is on the label, it's 15. And then I do 75 times 15 divided by 25. And if memory serves me correct, the answer is 45 drops per minute. So for every type of these flow rate questions, you're always going to do flow rate, volume over time, times the drop factor, and that will give you the drop rate. The only thing you're really going to have to do is sometimes you might have to convert minutes or hours to minutes, and that's really the only variation with these flow rate questions. Everything else is just practice, practice, practice. So with 17 says patient must receive a tube feeding of Ensure 120 milliliters in 90 minutes, and we want to calculate the flow rate in milliliters per hour. So flow rate is always going to just be volume over time. So 120 milliliters, 90 minutes. But I don't want minutes, I want hours. So the straightforward way to answer this is just to say 60 minutes, 1 hour, and then you're going to get your answer. The other way you can say do is, well, you know that 90 minutes is the same thing as 1.5 hours, right? So you could divide 120 by 1.5. But if you don't like that shortcut, if you just remember to convert minutes to hours, you'll be good to go. 120 times 60 is 7,200 divided by 90 will give you 80 milliliters per hour. Now, the other thing is, let's think about this from a just taking a step back, and so you don't accidentally like put the 60 in the wrong place. or multiply by 1.5, like 120 by 1.5, like I had mentioned in a previous review session. Think about it this way. It's 120 milliliters in 90 minutes. So in 60 minutes, it's going to be less than 120 milliliters. Okay. In 2 hours, it'll be more than 120 milliliters. So just keep in mind, like looking at the real numbers, the real volume, the real time, and then just try and rationalize, okay, is my answer going to be more or less than the 120? And the reason it's going to be less is because less time has passed. So you couldn't have administered more like that. You couldn't have administered 120 milliliters in 60 minutes because you didn't administer that until after 90 minutes. At least that was what the expectation was. And then when you're setting the infusion pump, you can't set it to per 90 minutes. You can only set it for per hour. So, but the simple way is when you have the 120 milliliters over the 90 minutes, multiply by 60 minutes, and that will get you your conversion to get to milliliters per hour. All right. Someone asked about doing number 10. Absolutely. Make sure I didn't miss anything. Okay. Well, so 10. It's a good one. All right. So we have a couple pieces of information for number 10. So the first thing is it tells us that we have, I'm just going to fold this down. We have a 0.375 grams to be administered every 6 hours. Available is 125 milligrams per 5 ml. And we want to know how many milliliters to give per dose. And then don't forget to mark the cup. The reason this question typically gets missed is because you didn't mark the cup. The other thing is use the cup as a guide. Your answer is on the cup. Okay. So it limits like what the questions can be as far as this type of question. So the first thing is my order is the 0.375 grams of amoxicillin. The problem with that is we can't work with grams, and then with my order being the 125 milligrams per 5 ml, I have milligrams and I have grams. You have to convert one to the other so they're both in the same unit. If you don't do that, your math won't come out. So my recommendation is to convert grams to milligrams. And the shortcut is just move your decimal over 3 to the right. If you don't feel comfortable doing that, you can practice just by you multiply by 1,000, or you can set up your conversion of going from grams to milligrams. But the shorthand is just move it 3 to the right, and you'll have 375 milligrams. Keep in mind that you'll always have, like, grams is a bigger number. So like 1 gram is 1,000 milligrams. So point something grams is going to be in the hundreds place, if that helps. But if you're going towards milligrams, move it to the right. If you're going towards grams, move it to the left. Now I have something I can work with. So I'm going to take my order, the 375, and I'm going to convert that to milliliters. So I have milliliters, I have milligrams, 5 milliliters, 125 milligrams. And then what I'm going to get is my answer here is going to be 15 milliliters. Okay. So, and I just want to double check that because I'm doing that from memory. 375 times 5 divided by 125. Yeah, 15. So I'm going to find 15 milliliters and I'm going to mark the cup. Okay. I'm going to mark the cup. Make sure you mark the cup at 15 milliliters. So with number 18, with going in the infusion time, what we're looking at is we have a total volume, okay, the total bag which is 500 milliliters, and then it's infusing at 125 milliliters per hour. And the question is, how long will that take? Basically, how long will it take to go from 500 milliliters to 0 milliliters? How long will that take? Okay. So the other way of just wrapping your head around it, it's kind of like, if you're traveling 500 miles and you're going 50 miles per hour, how long is it going to take you to get to your destination, assuming no stops and things like that? You're going to do, it's the same premise. Okay. So I'm going to take my 500 milliliters, and what I'm going to do is I'm infusing at 125 milliliters per hour. So I don't want milliliters, I want hours. 125, 1 hour. 125 goes into 500 4 times. So it's going to take 4 hours for this IV to empty at a rate of 125 milliliters per hour. The only thing that would change the time here is what is the actual infusion rate. So if it was 125 milliliters per hour, if it's 100 milliliters per hour, it's 50, is it 250, whatever it is, that would dictate how long it would take for us to empty that bag.